Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry A-Levels Multiple Choice, Paper 12 from May-June 2018. You can go to any particular question by following timestamps given in the video description. Let's start. Question 1. Which feature is present in both ethene and polyethene? Ethene is C2H4. We have double bond between two carbon atoms. The structure will be like this. In polyethene, polymer is formed from these ethene monomers. So what happens that double covalent bond is converted into single covalent bond and long chain of carbon atoms is formed. A, bond angles of 109 degrees. As we can see that in ethene, 3 atoms are present around the central carbon atom. So now bond angle will be 120 degrees. While in polyethene, around central carbon atoms, 4 bonds are present, or 4 elements are attached with single covalent bonds. So the bond angle will be 109.5 degrees. So option A is incorrect. B, pi covalent bonds are present in both ethene and polyethene. As we can see that in ethene, pi bond is present along with sigma bond. The first bond is always sigma bond and the second covalent bond that is formed is always pi bond. While in polyethene we can see that all bonds are sigma bonds. There is no pi bond that is present. So B is also incorrect. C, sigma covalent bonds. Now we can see that sigma covalent bonds are present in ethene and sigma covalent bonds are also present in polyethene. So therefore C is correct option. D, sp3 orbitals. Now hybridization of orbitals can be found by looking at the central atom. In the first one we have ethene, so the central atom is carbon. Now carbon is directly bonded to 3 other atoms. So we can write 3 plus number of lone pairs on carbon, which is 0, it equals 3. If the number equals 3, then it will be sp2 hybridization. If the number equals 4, then it will be sp3 hybridization. If this number equals 2, then it is sp hybridization, and also the shape of orbital is sp3 or sp2. Similarly, in polyethene, we can see that the central carbon atom is bonded to 4 elements directly. So it is 4 plus number of lone pairs, which is 0. Now 4 means that the hybridization is sp3. So we can see that in polyethene sp3 orbitals are present, while in ethene sp2 orbitals are present. Therefore D is incorrect. Correct answer is therefore C. Question 2. The electronic configuration of an atom of sulfur is given. We have 3s2, 3p4. How many valence shell and unpaired electrons are present in one sulfur atom? We have numbers 1, 2, 3. Now these numbers represent the principal quantum number. It also represents the number of shells. So we can see that there are 3 shells present in one atom of sulfur. So in total we have 3 number of shells. As the electronic configuration ends in 3s and 3p. As third shell is the outermost shell, now the number of electrons present in the outermost shell is 2 plus 4, which comes equal to 6. So we have 6 electrons in the valence shell or outermost shell. Let's do the electronic configuration. For third shell we have 3s and 3p. 3p is further divided into 3 orbitals, 3px, 3py and 3pz. In s we have 2 electrons, so 2 electrons are present. In p we have 4 electrons, so first electrons are added in unpaired form, then pairing starts. Now we can see that 2 unpaired electrons are present in p orbital, so therefore number of unpaired electron is 2. And number of valence shell electron is 6 in total. So we can see that the answer is D. Question 3. In which pair does the second substance have a lower boiling point than the first substance? Now the compounds given are simple molecular substances, so therefore the boiling point will depend on the intermolecular forces of attraction. Stronger intermolecular forces of attraction means higher boiling point, and weaker intermolecular forces of attraction means lower boiling point. Let's look into the first one. We have ethane, C2H6 and chloroethane. Now the electronegativity difference between carbon and hydrogen is not much, so therefore ethane is non-polar compound. While in C2H5Cl we have chlorine atom present that is more electronegative, so it will bear partial negative charge, so therefore this compound is polar in nature. Now in polar compound, dipole-dipole interactions are present, while in non-polar, dipole-dipole interactions are absent. So therefore the second substance would have higher boiling point as compared to the first one. So A is incorrect. In B we have CH3OCH3, which is ether, and second is ethanol. Now we can see that in CH3OCH3, oxygen is not directly bonded to hydrogen atom, so therefore hydrogen bonding will be absent. There is no hydrogen bonding in this compound. While in C2H5OH, which is alcohol, we have oxygen atom directly bonded to hydrogen atom, so therefore oxygen will bear a partial negative charge and hydrogen will become partial positive. Now it can do hydrogen bonding with the other ethanol molecule. So therefore hydrogen bonding is present in ethanol and it is absent in ether. So therefore ethanol would have higher boiling point as compared to ether. So B is also incorrect. C, we have neon and argon. The atomic number of neon is 10 while that of argon is 18. It means that neon has 2 electron shells that are present. In first shell we have 2 electrons, in second shell we have 8 electrons. In argon we have 3 electronic shells. In first shell we have 2 electrons, in second we have 8 electrons, in third we have 8 electrons. Now the number of electrons is directly proportional to the intermolecular forces of attraction or interatomic forces of attraction. So therefore greater forces will be present in argon as compared to neon. So the boiling point of argon should be higher than that of neon. C is also incorrect. For D we have CH3NH2, which is methylamine, and C2H6, which is ethane. Let's draw the structure of both CH3NH2. Now we can see that nitrogen is directly bonded with hydrogen atoms. So therefore hydrogen bonding will be present as nitrogen becomes partial negative and hydrogen is partial positive. So it can attract nitrogen atom of another molecule. In C2H6 we have ethane, which is non-polar in nature as the electronegativity difference between carbon and hydrogen is not much. So therefore no hydrogen bonding is present in ethane. So the boiling point of ethane will be lower than the boiling point of methylamine. So D could be the correct answer. Question 4. Compound J burns in excess oxygen to give CO2 and water only. When a 3 grams sample of compound J is burnt in excess oxygen, 4.40 grams of carbon dioxide and 1.80 grams of water are formed. What is the empirical formula of J? The options given are CH, carbon is 12, hydrogen is 1, so the molecular mass is 13. Second is CHO. Third is CH2. Fourth is CH2O. Three grams of sample J is present, so we can find out the moles, as number of moles is equal to mass in grams divided by molecular mass. So for CH it will be 3 divided by 13. It comes equal to 0.23 moles. For CHO it will be 3 divided by 29. It comes equal to 0.103 moles. For CH2, it is 0.214 moles. For D, we have 30 molecular mass, so 3 divided by 30. It comes equal to 0.1 moles. Let's find the moles of carbon dioxide and moles of water. Carbon dioxide is CO2. The molecular mass comes equal to 44. Water is H2O. The molecular mass comes equal to 18. So 4.40 grams divided by 44. The number of moles come equal to 0.1 moles. For water, 1.80 grams divided by molecular mass, which is 18. It also comes equal to 0.1 moles. Let's write the balanced equation for the combustion of compound J in excess oxygen. We have carbon, hydrogen, oxygen. Excess oxygen is present and carbon dioxide and water are formed. As we can see that in all the reactants, the number of carbon atoms is 1. So as the equation is balanced, so it means the number of carbon atoms present in CO2 must be equal to the number of carbon atoms present in this compound. As we can see that 0.1 mole of CO2 is formed upon complete combustion and 0.1 mole of water is formed upon complete combustion. So therefore, as the number of atoms is equal, so the number of moles should also be equal. So 0.1 mole of compound J burns to form 0.1 mole of carbon dioxide and 0.1 mole of water. Now we have number of moles. We also have mass, which is 3.00 grams. Now we can find the molecular mass of this compound J by using the formula. Molecular mass equals mass in grams divided by number of moles. So mass in grams is given, which is 3.00 grams divided by number of moles, which we have found out, which is 0.1. So the molecular mass comes equal to 30. As we can see that the molecular masses given is 13, 29, 14 and 30. So therefore D seems to be the correct option. The answer is therefore D. Question 5. The gases X and Y react to form Z. This is the equilibrium expression. An equilibrium mixture of these three gases is compressed at constant temperature. What will be the changes in the mole fraction of Z and in Kp? Mole fraction is the portion of moles of Z in equilibrium. Now we can see that we have 1 mole of X and 1 mole of Y, which combine to form 1 mole of Z. Now the number of moles of reactant is 2 while the number of moles of product is 1. So at higher pressure, when the gases is compressed, what happens that the equilibrium will move in the forward direction from more number of moles to less number of moles. So therefore the mole fraction of Z will increase. Second thing is Kp. Now we know that Kp or Kc is only affected by temperature. It is not affected by concentration or pressure or catalyst. As temperature is constant, so therefore Kp will not change. The answer is therefore B. Question 6. Which gas is likely to deviate most from ideal gas behavior? Now ideal gas is the one that has no intermolecular forces of attraction or repulsion between its molecules, and in ideal gas there is no loss of energy upon collisions. Now the gas that would have intermolecular forces and loss of energy would be the one that is deviating from ideal gas behavior. In A we can see that we have HCl. Hydrogen is partial positive, chlorine is partial negative, so we have intermolecular forces of attraction. Because this molecule is polar, so it will deviate from ideal gas behavior. In B we have helium. Helium is a noble gas, so therefore there is no charge and no force of attraction. Helium is the one that will be the most close to ideal gas behavior. So B is incorrect. C is methane, which is CH4, and we know that there is not much electronegativity difference between carbon and hydrogen, so therefore this is non-polar molecule. As the number of atoms are greater as compared to helium, so it will deviate a little bit from ideal gas behavior, but as there are no charges present, so therefore the deviation will not be the most. In D we have nitrogen. Again, nitrogen is a neutral molecule. Both atoms are present of nitrogen, so therefore no charges are present. So this gas is also close to ideal gas behavior. The only gas that deviates most is HCl. Question 7. The enthalpy change of reaction 1 is minus 114 kilojoules per mole. This is reaction 1. We can see that alkali and acid, they react to form salt and water. By using this information, what is most likely value for the enthalpy change of reaction 2? In reaction 2, we can see that alkali and acid are reacting to form salt and water. So both reaction 1 and reaction 2 are neutralization reactions. In both reactions, we can see that 2 moles of water are being produced upon neutralization. As in NaOH, we have 2 hydroxide ions that combine with 2 H plus ions from sulfuric acid. So it forms 2 water molecules. Similarly, in barium hydroxide, we have 2 hydroxide ions that combine with H plus. Now 2 moles of HCl are present, so therefore the number of moles of H plus will be 2, and it combines to form 2 moles of water. So the ionic equation is exactly similar in both, so therefore the energy change will also be same. Reaction 2 will also show negative 114 kilojoules per mole energy change. Question 8. Sulfur reacts with concentrated nitric acid in a redox reaction. We have sulfur, HNO3, sulfur dioxide, NO2 and water are formed. What are the changes in oxidation number of sulfur and of nitrogen in this reaction? Let's first find out the oxidation states. Sulfur is in the form of element, so the oxidation state is 0. Then we have SO2. In SO2, we have 1 sulfur and 2 oxygen. The oxidation state of 1 oxygen is negative 2, so for 2 it will be negative 4. Overall charge is 0, so sulfur equals plus 4. So from 0 to plus 4, the change in oxidation state of sulfur is plus 4. Now looking at nitrogen, we have HNO3 and NO2. In HNO3, we have 1 hydrogen, the oxidation state is plus 1. There are 3 oxygens, so the oxidation state will be negative 6, overall charge is 0. So nitrogen is equal to plus 5. In NO2, we have 2 oxygen atoms, overall charge is 0, nitrogen equals plus 4. So from plus 5 to plus 4, the change in oxidation state is negative 1. Answer is therefore D. Question 9. Materials can be classified by their chemical structures. 4 common types of structure are metallic, ionic, simple molecular and giant molecular. Some physical properties of 4 substances are shown in the table. Which substance has a simple molecular structure? Now we know that in simple molecular structure, weaker intermolecular forces are present, so therefore the melting point and boiling point should be low. Ionic and metallic bonds have high melting points, so therefore for simple molecular structure the melting point could be 64 and 113. 767 is for ionic bond and 1600 is for giant molecular structures. Second thing is the effect of adding water. Now for majority of simple molecular structures, they are insoluble in water, for example hydrogen, nitrogen, methane, ethane, etc. Third thing is the electrical conductivity. Now the electrical conductivity of simple molecular structure is always bad. That is because there are no free electrons or no free ions present. And as they are insoluble in water, so therefore the electrical conductivity will always be poor. The answer is therefore B. Question 10. In a particular reversible reaction, the yield of product is increased if the temperature is increased, if the pressure is decreased. Which equation could describe this reversible reaction? Now we know that if the temperature is increased for endothermic reaction, the reaction will go in the forward direction and more product is formed. So the reaction must be endothermic. So it could be this one or this one, as the enthalpy change is positive for endothermic reaction. Second thing is pressure. Now we know that when pressure is decreased, the reaction will move from less number of moles to more number of moles. So it means that the number of moles of product should be greater than the number of moles of reactant. So in A we have 1 mole of CH4, 1 mole of water, 3 moles of hydrogen gas and 1 mole of carbon monoxide gas. Now the number of moles of product is greater than the number of moles of reactant. So therefore the reaction will move from less number of moles to more number of moles, or we can see that more product is formed. So therefore the yield of product is increased. So A is correct for both options. For part D, we can see that we have more number of moles of reactant and less number of moles of product. So the reaction will move in backward direction upon decreasing pressure. So therefore the yield of product will decrease. As we are looking at the increased yield, so therefore D is incorrect. Correct answer is therefore A. Question 11. A chemical company used a catalyst in a chemical process. The company has now decided not to use the catalyst but to increase the temperature so that the rate of reaction is the same as it was when the catalyst was used. So they have increased temperature instead of using catalyst. Which statement about the new conditions compared to the original conditions is correct? In original conditions we had catalyst. In new conditions we have increased temperature. And no catalyst is present. A. The activation energy has been decreased. As we can see that we have removed catalyst in new conditions, so therefore activation energy has increased, it has not decreased. B. The activation energy has been increased. Now this is true because we have removed catalyst, so the removal of catalyst will increase the activation energy in new condition. C. There are fewer successful collisions per unit time. As we can see that in new conditions we have increased the temperature and removed the catalyst, so therefore there is no effect on successful collisions. So this is incorrect. This can also be seen from the fact that rate of reaction is the same as it was when the catalyst was used. So when the rate of reaction is same, the number of successful collisions will also be same. This will not be fewer or more. The answer is therefore B. Question 12. Which oxide does not react with cold dilute sodium hydroxide to produce a salt? In the options we have aluminum oxide. Aluminum oxide is amphoteric oxide. It can react with both acid and alkali to form salt. So when aluminum oxide is reacted with sodium hydroxide, it will form salt and water. So A is incorrect. B is P4O10, which is phosphorus oxide, and as it is a non-metal oxide, so therefore it is acidic in nature. Acidic oxide also reacts with sodium hydroxide to form salt and water. So B is also wrong. In C we have sulfur dioxide. Again, sulfur is a non-metal, so its oxide is acidic in nature. It will also react with dilute called sodium hydroxide to form salt. So C is also wrong. D is SiO2. Now SiO2 is not much reactive, so therefore it cannot react with cold dilute sodium hydroxide. It will react with hot concentrated sodium hydroxide. So D is the correct option. Question 13. The graphs show trend in 4 physical properties of elements in period 3 excluding argon. Which graph has electronegativity on the y-axis? Now, electronegativity is the tendency of an atom to attract a shared pair of electrons towards itself. For example, when hydrogen and fluorine they make a bond, fluorine is more electronegative, so this pair will be attracted towards fluorine. That's why fluorine becomes partial negative and hydrogen becomes partial positive. Now, electronegativity depends on 2 factors. One is the size of atom. Electronegativity is inversely proportional to the size of atom, and it is directly proportional to nuclear charge. So along the period in period 3, the atomic size decreases. So therefore electronegativity will increase. The nuclear charge increases as the number of protons in the nucleus increase, so therefore electronegativity will also increase. So the only graph that represents the increase in electronegativity is D. As we can see that the electronegativity of sodium is lower than magnesium, than aluminum. It is increasing as we are moving along the period. The answer is therefore D. Question 14. In this question, X represents an atom of chlorine, bromine or iodine. Which explanation for the variation in volatility down group 17 is correct? As we know that in group 17 what happens that the elements become solid from gas. So therefore intermolecular forces increase and volatility decrease. A. We have instantaneous dipole. Induced dipole forces between molecules become stronger. This is a true statement because the instantaneous dipole and induced dipole forces, they depend on the size of atom. So as we can see that from chlorine to bromine to iodine, the size of molecule increases, so therefore these forces will also increase, and because of these forces the state will become from gas to liquid and liquid to solid. B. Permanent dipole forces between molecules become stronger. This is incorrect because the molecules are made up of similar atoms, so there are no opposite charges present, so permanent dipole forces are absent. Part C. The bond energy of X2 molecule decreases. This is a true statement because the bond energy of fluorine is very high as compared to the bond energy of iodine. But this has nothing to do with the volatility, as volatility does not depend on bond energy, it depends on intermolecular forces. So C is also incorrect. Part D. The first ionization energy decreases. Now the first ionization energy will decrease down the group as the electron is moving farther from the nucleus. So this is also a true statement. But again, it does not have anything to do with the volatility, as volatility depends only on the intermolecular forces of attraction. So D is also incorrect. Correct answer is therefore A. Question 15. To manufacture cement, 1000 million tons of limestone are decomposed each year. To manufacture lime for agriculture, 200 million tons of limestone are decomposed each year. What is the total mass of carbon dioxide in million tons produced from these two processes in a year? As the unit is taken as million tons, so for easiness we can use grams. We will use grams for this one, grams for this one, and grams for answer. Let's write a balanced equation for the decomposition of limestone. Limestone is calcium carbonate. It decomposes at higher temperature to form calcium oxide and carbon dioxide gas. The equation is already balanced, so we have 1 mole of calcium carbonate that produces 1 mole of CO2. Now in the question we have 1000 grams of limestone and 200 grams of limestone, so in total we have 1200 grams present. The mass of carbon dioxide is to be calculated. Let's find the molecular masses. For calcium carbonate, we have 1 calcium atom, so it is 40. 1 carbon, 12, 3 oxygen becomes equal to 48, so in total the molecular mass is 100. So we can change mass in grams into moles by using formula. Number of moles is equal to mass in grams divided by molecular mass. So 1200 grams divided by 100, it is 12 moles. As from balanced equation we can see that 1 mole of calcium carbonate produces 1 mole of CO2. So 12 moles of calcium carbonate will form 12 moles of CO2. The molecular mass of CO2, we have 1 carbon atom, 2 oxygen atoms. So Mr is equal to 44. Now we can use the formula mass is equal to moles into Mr. So it is 12 into 44. It comes equal to 528 grams. So in the options we can see that answer is B. Question 16. In group 2 of the periodic table, the properties of elements and their compounds show regular change down the group. Which property shows a decrease from magnesium to barium? First is the decomposition temperature of the carbonates. Now the carbonates of group 2 become more strong as we go down the group. This is because the size of cation increases and the size of anion is already larger. So therefore more overlap is present. Also the polarizing power of cation decreases, so therefore the decomposition temperature of carbonate will increase. So A is incorrect. B is the decomposition temperature of the nitrates. It is similar to carbonates because in nitrates also cations and anions is present and the size of anion is quite larger. So from magnesium nitrate to barium nitrate, the decomposition temperature will increase. This is because size of cation increases and polarizing power of cation decreases. So B is also incorrect. C, the solubility of hydroxides. Now we know that magnesium hydroxide is less soluble, and as we move down in the group, barium hydroxide is very much soluble in water. So the pH of barium hydroxide is quite high, it is equal to 13. So the solubility of hydroxide increase, so therefore C is also incorrect. D, the solubility of sulfates. Now in sulfates we can see that magnesium sulfate is more soluble as compared to barium sulfate, which is insoluble and it forms a precipitate. So the solubility of sulfates decrease from magnesium to barium. So D is the correct option. Correct answer is therefore D. Question 17. When concentrated sulfuric acid is added to solid sodium bromide, bromine gas is produced along with a number of other products. However, when concentrated sulfuric acid is added to solid sodium chloride, only hydrogen chloride and sodium hydrogen sulfate are produced. What is the reason for this difference? We can write the equation. Concentrated sulfuric acid is H2SO4. It reacts with sodium bromide, NaBr. The oxidation state of Br is -1 to form bromine gas. So the oxidation state is 0 along with the number of other products. However, in second reaction we have concentrated sulfuric acid that reacts with sodium chloride. The oxidation state of chlorine is -1. The product formed is HCl and sodium hydrogen sulfate. NaHSO4 along with HCl. Now in HCl we can see that the oxidation state of chlorine has not changed. So it means that sulfuric acid can oxidize bromide to bromine, but it cannot oxidize chloride to chlorine. Let's move towards the options. In A we have bromine is less volatile than chlorine. Now this statement is true, but it has nothing to do with this chemical reaction, as in this reaction oxidation and reduction is involved. B. Hydrochloric acid is a weak acid. This is a wrong statement and it has nothing to do with this chemical reaction. C. Sulfuric acid is not an oxidizing agent. This is also incorrect because we can see that sulfuric acid is making bromide go into bromine. So oxidation of bromide takes place. So therefore sulfuric acid is acting as an oxidizing agent. Part D. The bromide ion is a stronger reducing agent than the chloride ion. Now this is a true statement because chloride ion is not a stronger reducing agent as compared to bromide, because bromide is being oxidized to bromine while chloride does not oxidize to chlorine. Its oxidation state is still the same in the product. So therefore bromide ion is a stronger reducing agent than chloride ion. The answer is therefore D. Question 18. The dative covalent bond can be represented by an arrow. This arrow points towards the atom receiving the lone pair. Which diagram of an ammonium ion is correct? Ammonium ion is formed when lone pair from nitrogen atom it is donated to H+. So therefore the arrow will be like this. And overall the charge will be positive. So therefore the structure similar to this one is given in part C. Question 19. Sulfur dioxide can be catalytically oxidized by an oxide of nitrogen in the atmosphere. Which reaction shows the regeneration of the catalyst? The reaction in which sulfur dioxide is oxidized by an oxide of nitrogen is given as this one. SO2 gas. In atmosphere it reacts with NO2 gas to form sulfur trioxide along with nitrogen monoxide. Now in second reaction what happens that nitrogen monoxide is oxidized in the air to form nitrogen dioxide gas. So now we can see that NO2 is being regenerated in the product, so therefore it is acting as a catalyst. So this equation represents the regeneration of catalyst and it is given in part D. Question 20. Compound Y is treated with an excess of hydrogen gas in the presence of nickel catalyst. The product is fully saturated. This is compound Y. We can see that we have alkene functional group present. What is the number of chiral carbon atoms in the product? As we have hydrogenation reaction in the presence of nickel catalyst, so what happens that the double bond is converted into single bond upon hydrogenation. So now each double bond is converted into single bond. So this is the product that will be formed. Now looking at the number of chiral carbon atoms. Chiral carbon means such a carbon that is attached with 4 different elements or groups. Now let's look at the compound which carbon is chiral. This is the corner carbon, so it is attached with 3 hydrogen atoms as it is CH3, so therefore this is not chiral. This is the second carbon atom which is attached with 3 different groups. One is CH3, one is this one is this one, and one hydrogen atom is also present. So therefore this is chiral. This carbon is attached with 2 hydrogen atoms, so therefore it is not chiral. This is attached with 2 hydrogen atoms, so this is not chiral. This is attached to 3 different groups, so one is this side, one is this side, one is this side, and one hydrogen atom is also present, so therefore this is also chiral. Again, now looking at this carbon atom, we can see that 2 similar CH3 are present, so therefore this is not chiral. The corner carbon atoms are not chiral as they have 3 hydrogen atoms each. Now looking at this carbon atom, we have 3 different groups attached and one hydrogen atom is also present, so this is chiral. Again we have CH2, not chiral, CH2, not chiral. This carbon is attached with 3 different groups. One is this side, then we have this side, then we have CH3 and hydrogen atom is also present. So this is chiral carbon. This carbon is attached with 2 hydrogen atoms. This is attached with 2 hydrogen atoms, 2 hydrogen atoms. So these 3 are not chiral. This carbon is making bond with 3 different groups and one hydrogen atom is also present. So therefore this is chiral. This carbon is not chiral as it has 3 hydrogen atoms. This one has 2 hydrogen atoms. This one has 2 hydrogen atoms. So now we can see that we have 1, 2, 3, 4, 5 chiral carbons present in the product. The answer is therefore A. Question 21. Which equation represents a valid propagation step in the chlorination of ethane? In the propagation step, what happens that radical is present on the reactant side and radical is also present on the product side. So we can see that in D, radicals are present on the reactant side, but there is no radical present on the product side. So therefore this is not propagation, it is termination step, as radicals are being converted into neutral molecule. Looking at option A, we have C2H6 that reacts with chlorine radical, and what will happen that chlorine radical will take out hydrogen to form HCl. So the product will not be this one, the product will be C2H5 radical along with the molecule of HCl. So A is incorrect. In part B, we can see that chlorine radical is present, so it will take one hydrogen atom to form HCl and rest of the molecule converts into radical. So B seems to be correct. Part C, we can see that C2H5Cl is being attacked with hydrogen radical. Now this is not possible because in chlorination, chlorine radical is present instead of hydrogen radical. So C is incorrect. Correct answer is therefore B. Question 22. Maleic acid is used in food industry and for stabilizing drugs. It is the cis isomer of butene dioic acid and has the structural formula this one. We have alkene functional group, we have carboxylic acid functional groups. What is the product formed from the reaction of maleic acid with cold dilute acidified manganate 7 ions? Now you should know that cold dilute acidified manganate ions, they convert alkene to diol upon oxidation. Diol is the one in which each carbon atom making a double bond is attached with OH group. So this is the product that will be formed for alkene, while carboxylic acid will be unchanged. So for this compound we can see that we have C double bond O, OH on one side, then we have carbon hydrogen, double bond, then carbon hydrogen, then again carboxylic acid functional group. So upon reaction with cold dilute acidified manganate ions, what will happen that this double bonded carbon will be converted into diol. So the product formed will be OH on this carbon atom, double bond converted into single bond, OH on this carbon atom. We can also write the formula like this. We have CO2H on one side, then we have CH, OH is as a substituent, then again we have CH, OH is acting as a substituent, then we have CO2H. Now we can see that this product is exactly similar to the one given in part A. Question 23. Primary halogenoalkanes undergo hydrolysis reactions. Which reaction would occur most rapidly if they are all warmed to the same temperature? Now hydrolysis is the reaction in which we have water that is used to break down the molecule. So we can say break down by water. With water, what will happen that C2H5Br is converted into alcohol, that is C2H5OH along with HBr. Similarly, with sodium hydroxide, what will happen that the product formed will be C2H5OH, that is alcohol, along with sodium bromide. Now the reaction rate depends on two things. First is the carbon halogen bond. We have carbon bromine bond, and in next two options we have carbon chlorine bond. Now the carbon chlorine bond is more strong. It needs 346 kilojoules per mole to break, while carbon bromine bond is comparatively weak. It will need only 290 kilojoules per mole to break. So therefore the reaction involving breakage of carbon bromine will be faster as compared to the reaction involving carbon chlorine. So it could be this one or this one. Second is the nucleophile. We have H2O and NaOH. Now OH negative nucleophile from NaOH is more effective as compared to the nucleophile from neutral water. So therefore the reaction will be faster with sodium hydroxide aqueous as compared to neutral H2O, that will be slower. So the reaction will be faster if we have carbon bromine bond and sodium hydroxide aqueous is used. Question 24. Structural isomerism and stereoisomerism should be considered when answering this question. A colorless liquid C5H11Cl exists as a mixture of two optical isomers. When heated with sodium hydroxide in ethanol, a mixture of only two alkenes is formed. What could the colorless liquid be? Now for halogenoalkane, the reaction in sodium hydroxide in ethanol is elimination reaction. In elimination reaction, small molecules are eliminated. In this compound we have Cl, so HCl will be eliminated and alkene will be formed. In the question they have given that a colorless liquid, this halogenoalkane exists as a mixture of two optical isomers. It means that chiral carbon is present. Let's look into the options. In A we have this compound. Let's draw the structure. We have CH3, CH2, CH, CH3, CH2, and Cl is also present. Now as we can see that with this carbon atom, two similar groups are present. So therefore this is not chiral. So as chiral is not present, so therefore optical isomer will be absent. So A is incorrect. Let's draw the structure of B. We have CH3, CH2, CH2. Then we have carbon having hydrogen and chlorine. Then we have CH3. As we can see that this carbon is bonded with 4 different groups, so therefore this is chiral carbon. So 2 optical isomers will be formed. Second process is elimination of HCl. So from one carbon atom chlorine will be removed, and from adjacent carbon, which could be this one or this one, hydrogen atom will be removed. So the first product formed if hydrogen atom is removed from this carbon would be like this. We have CH3, CH2, CH. Now double bond is formed between these 2 carbon atoms. So this product is formed. Now in this product we can see that this carbon is making double bond, again this carbon is making double bond, and both carbon atoms making double bond have 2 different groups attached. One is hydrogen, one is CH3, CH2. On second side we have one hydrogen and one CH3. So therefore this will show cis-trans isomerism. So one product is cis, one product is trans. In second scenario, if the hydrogen atom is removed from this carbon, then the product form will be like this. We have CH3, CH2, CH2. Then we have carbon atom with hydrogen. Now a double bond is formed between these 2 carbon atoms. Now in this product we can see that this carbon and this carbon are making double bonds. Now with this carbon we can see that both atoms are same, so therefore cis-trans will be absent, only this product is formed. So in total we have 1, 2, 3 products that are formed, and all 3 are alkenes. As in the question, only 2 alkenes were formed, so therefore B is incorrect. Now looking at part C, we have this structure. CH3 is attached with carbon having hydrogen atom. Then CHCl and CH3. Now we can see that this carbon is not chiral as it has 2 similar CH3 groups. This carbon is chiral as it has 4 different groups. So first option is correct. Now for second option we have elimination reaction. So chlorine will be removed from this carbon and hydrogen can be removed from this carbon atom or from this carbon atom. So 2 possible structures are formed. In first one we have CH3, CH, CH3. Then we have carbon, hydrogen, and if hydrogen is removed from this carbon atom, then double bond will come between these 2 carbons. Now as double bonded carbon is attached with similar atoms, so only this product is formed, there will be no trans isomer. In second scenario, if hydrogen atom is removed from this carbon atom, then the product form will be like this, CH3. Then we have carbon double bonded with this carbon, and we have CH3. Now as with this double bonded carbon we can see that similar groups are attached, so therefore cis-trans is not possible, only this product is present. So in total we have 2 alkenes that are being formed, so second option is also correct. So C could be the correct answer. Now moving towards part D, we have CH3, CH2. Then we have carbon having chlorine, CH3 and CH3. Now with this carbon we can see that 2 similar groups are present, so therefore no chiral carbon is present. So option D is incorrect. Correct answer is therefore C. Question 25. When warm water is added to halogenoalkane X, an SN1 reaction occurs. Silver nitrate aqueous is then added, a yellow precipitate is formed. What could be X? SN1 mechanism is shown by tertiary halogenoalkanes. Let's see which option shows tertiary halogenoalkane. First one is 1-chlorobutane. So we have 4 carbon atoms in the long chain and chlorine is present on first carbon. As the carbon attached with chlorine is further attached to 1 carbon atom, so this is primary halogenoalkane. So 1 is incorrect. In B we have 1-iodobutane. So again we have 4 carbon atoms in the long chain and on first carbon atom iodine is present. So as this carbon that is attached with iodine is attached only with one carbon atom directly, so this is also primary halogenoalkane. So both A and B are incorrect. In part C, we have 2-chloro, 2-methyl-propane. So in long chain, we have 3 carbon atoms as it is propane. On second carbon, we have chloro, and on second carbon, we also have methyl functional group. Now as we can see that the carbon atom attached with chlorine is attached to 3 carbon atoms directly, so this is tertiary halogenoalkane. So this will follow SN1 mechanism. And the precipitate that is formed with silver nitrate is silver chloride. Now AgCl is silver in color, while in question yellow precipitate is formed, so therefore C is incorrect. In part D, we have 2-iodo, 2-methylpropane. Again, we have 3 carbon atoms in the long chain. On second carbon, we have iodo and methyl. As the carbon atom attached with iodine is further attached with 3 carbon atoms directly, so this is tertiary halogenoalkane. And it will follow SN1 mechanism. Second thing is the formation of precipitate. As we have iodine, so it will form AgI with silver nitrate. And AgI is yellow in color. So as in the question, yellow precipitate was given, so therefore D could be correct option. The answer is therefore D. Question 26. Which alcohol will react with an acidified solution of potassium dichromate 6 to produce a ketone containing 6 carbon atoms? Now you should know that ketone is always formed from secondary alcohol. Let's find out the secondary alcohol. In A, we have 2,2-dimethylbutane 1-ol. So in the long chain, we have 4 carbon atoms as it is butane, and on first carbon we have alcohol. On second carbon atom we have 2 methyl groups. As we can see that the carbon atom attached with OH is directly attached to one carbon only, so therefore this is primary alcohol. So A is incorrect. Part B, we have 2-methylpentane 3-ol. In pentane, we have 5 carbon atoms. Alcohol is attached on third carbon. On second carbon, we have methyl group attached. Now as we can see that the carbon attached with OH is directly attached to 2 carbon atoms, so therefore this is secondary alcohol. Rest are the number of hydrogen atoms. We have 3. 1, 1, 2 and 3 hydrogens. Now upon oxidation it will form ketone. Alcohol is converted into carbonyl carbon. So now we have CH3, CH, CH3. Carbonyl will be formed upon oxidation. Then we have CH2 and CH3. Now we can see that in total we have 1, 2, 3, 4, 5, 6 carbon atoms. So as in the question, 6 carbon atoms ketone was formed, so therefore B could be the correct answer. Part C, we have 3,3-dimethylpentane 2-ol as it is pentane, so we have 5 carbon atoms in the long chain. On second carbon we have alcohol group attached. On third carbon atom we have 2 methyl groups attached. Now this is secondary alcohol because this carbon is attached to 2 carbon atoms directly. Now this will be oxidized to ketone. Now in the product we have 7 carbon atoms, so therefore C is incorrect. Part D, we have 3-methylpentane 3-ol. So we have 5 carbon atoms as it is pentane. On third carbon atom we have alcohol group attached. On third carbon atom we also have methyl group attached. Now we can see that the carbon atom bonded with OH is directly attached with 3 carbon atoms, so therefore this is tertiary alcohol. and tertiary alcohol cannot be oxidized further, so therefore D is also incorrect. Correct answer is therefore B. Question 27. Which statement about butanone is correct? Butanone is the ketone having 4 carbon atoms. Part A. Butanone can be dehydrated by concentrated sulfuric acid to give this alkene. This is incorrect because ketone cannot be dehydrated. It should be alcohol that is dehydrated. Part B. Butanone gives a positive results with Tollens reagent. Now this is also incorrect because Tollens reagent gives positive results only with aldehyde. Part C. Butanone reacts with HCN by an electrophilic addition mechanism. This is also incorrect because it is not electrophilic addition, it is nucleophilic addition. Because this reaction is initiated by CN, which is a nucleophile, and it will attack the partial positive carbon atom present in carbonyl carbon. So this is nucleophilic addition, not electrophilic addition. Part D. Butanone reacts with NaBH4 to give a chiral product. Chiral product is the one that have carbon atom having 4 different elements or groups attached. Now NaBH4 is a reducing agent and it can reduce ketone back to secondary alcohol. This is ketone, that is butanone. It can be reduced in the presence of NaBH4 to form secondary alcohol. In this product we can see that this carbon atom is attached with 1 hydrogen, 1 OH, 1 CH3 and 1 this product. So therefore this carbon is chiral carbon and therefore the product is chiral. The answer is therefore D. Question 28. Ethanol, that is aldehyde, is used to make product R in a 3-stage synthesis. 2 molecules of Q react to give 1 molecule of R plus 2 molecules of water. R has 2 ester functional groups in each molecule. R does not react with sodium. What is the empirical formula of R? This is ethanol, that is aldehyde. Upon reaction with HCN, nucleophilic addition will take place and hydroxynitrile product is formed. On the reactant we had CH3 C double bond OH. Now the product formed will be hydroxynitrile, that is CH3COH. Hydroxy group is now formed and CN is also attached with this carbon atom, so therefore this is called hydroxynitrile. So now this product is formed and it is product P. Now in second reaction, product P is converted into product Q upon reaction with sulfuric acid in reflux. Now what will happen that this CN will be converted into carboxylic acid and ammonium salt. Now the product upon acid hydrolysis will be CH3 C OH H COOH. This carbon is converted into carboxylic acid. So we can write product Q CH3 CH COOH OH. Now it says that 2 molecules of Q. In Q we have alcohol functional group and we also have carboxylic acid functional group. 2 molecules will react to give 1 molecule of R plus 2 molecules of water. And R has 2 ester functional groups. R does not react with sodium, it means that R would not have any OH group present. Now we can take 2 molecules of this product. One is CH3 CH OH, COOH, and then second molecule, that is CH3, CH, OH, COOH. Now esterification can take place. OH and H can be removed in the form of water and ester functional group is formed. Again, OH and H can be removed in form of water to form ester functional group. So now the product form will be like this. We have CH3, CH, oxygen, C double bond O. Now drawing second molecule, we have this oxygen bonded with this carbon atom. Then we have CH and also oxygen is present. And then we have CH3. Now we can see that two water molecules are formed. One is this one is this one. So minus 2 H2O. And we have two ester functional groups that are formed. One is this ester, second is this ester. This is product R, and product R does not react with sodium as there is no carboxylic acid functional group and no alcohol functional group present. Now finding out the empirical formula, we have 1, 2, 3, 4, 5, 6 carbon atoms. 8 hydrogen atoms and 4 oxygen atoms. So the simple ratio will be C3H4O2. So the empirical formula will be B. Question 29. The ester ethyl butanoate can be hydrolyzed using an excess of dilute sodium hydroxide solution. Which substance is a product of this reaction? Ester is ethyl butanoate, so we have 4 carbon atoms on the carboxylic acid side and 2 carbon atoms as it is ethyl on the alcohol side. So this is the structure of ethyl butanoate. Now it is hydrolyzed using excess of dilute sodium hydroxide. Upon hydrolysis, this carbon-oxygen bond is broken and carbonyl carbon is the carboxylic acid part. It will react with sodium to form sodium salt of carboxylic acid, while the alcohol part will react with OH to form alcohol. So the product form will be like this. We have CH3, CH2, CH2, then carbonyl carbon will make salt of carboxylic acid. We have NaOH, so it will be sodium salt of carboxylic acid. Upon second side, we would have alcohol group, so it will be CH3, CH2, OH. So we have sodium butanoate, so therefore A seems to be the correct option. Answer is therefore A. Question 30. The IR spectrum of an organic compound is shown. This is the spectra. We have this peak and this is also an important peak. Which compound could give this spectrum? Now from the spectra we can see that this peak is around 2950, so it will be of carbon-hydrogen bond. And this peak is around 1700 something, so it is because of the presence of carbonyl carbon. Let's look into the option. In A we have carboxylic acid. In carboxylic acid we have carbonyl carbon that is present in this spectrum. We also have carbon oxygen and oxygen hydrogen bond that is absent in this spectrum. So A is incorrect. The peak because of OH present in carboxylic acid should come around 2500 to 3000 per centimeter, and it is sharp and very broad. This peak is absent in this spectrum. B is alcohol. We have CH3, CH, OH, CH3. So we have secondary alcohol, and in alcohol OH is present. Now the peak because of OH is around 3200 to 3600, and it is also a sharp peak. As we can see that the peak is absent around 32 to 3600, so therefore it is also not alcohol. Part C is ketone. We have CH3, then carbonyl carbon, then CH3. In ketone we have carbonyl carbon that is present, and it is also present in the spectra. We also have carbon hydrogen bond that is also shown in spectra. The peak because of carbonyl carbon in ketone is around 1670 to 1740, and it is also a sharp peak. So as it is present, so therefore it could be ketone. In last one we have ketone functional group and alcohol functional group. So we have CH3, then carbonyl carbon, then CH2 and OH group. Now carbonyl peak is present around 1670 to 1740. We can see that it is around 1710, but OH peak is absent. So therefore it is not D. Correct spectrum is of ketone, which is C. Question 31. For complete combustion, 1 mole of an organic compound X requires 2.5 moles of oxygen. Which compounds could be X? We have 3 compounds. One is alcohol, one is alkene, one is aldehyde. Let's write the balanced equation for complete combustion. Carbon dioxide and water is formed. Again in second one, carbon dioxide and water is formed. Similarly, we have third one. Now let's balance the number of carbon atoms. On the right hand side we have 2 carbons, so it will be 2 CO2. We have 6 hydrogen atoms, so it will be 3 water molecules. Now balancing oxygen, we have 4 plus 3, 7 oxygen atoms on the product side. So as we have 1 oxygen atom on the right hand, so 3 moles of O2 will be required. As in the question, 2.5 moles is given, so therefore 1 is incorrect. Similarly in second one we have 2 carbon atoms, so we can balance by using 2 with CO2. 2 hydrogen atoms are present, it is already balanced. Now number of oxygen atoms is 4 plus 1, 5 in the product. Now we can write 2.5 with oxygen to make it 5. So as 2.5 moles of oxygen is required, so therefore 2 is correct. In third one we have 2 carbon atoms, so we can balance by using 2. 4 hydrogen atoms are present, so we can write 2 with water. Now 4 plus 2, 6 oxygen are present in the product. 1 is present here, so we can write 2.5 with oxygen to make it 5 plus 1, it will be 6. So 3 is also correct. As both second and third option is correct, the answer is therefore C. Question 32. In which pairs do both species have the same number of electrons? We can find atomic number from periodic table. Chlorine atomic number is 17. The atomic number of argon is 18. And for potassium it is 19. In the first one we have chlorine 1735, and as it is neutral, so we have 17 electrons. As the number of protons is equal to the number of electrons. Again in the second isotope we have 17 protons, so 17 electrons must be present. In isotopes only the number of neutrons differ, so therefore option 1 is correct. In option 2 we have negative charge on chlorine, so 17 plus 1 it will become 18 electrons. And on argon we have atomic number 18, so overall charge is neutral or 0, so therefore 18 electrons must be present. So 2 is also correct. In 3 we have argon neutral, so 18 electrons are present. In potassium 19 we have plus 1 charge, which means 1 electron is being removed, so 19 minus 1 will become 18 electrons. As all 3 options are correct, the answer is A. Question 33. For which reactions does the value of enthalpy change represent both a standard enthalpy change of combustion and a standard enthalpy change of formation? Now in standard enthalpy change of combustion, we can say that when 1 mole of substance is combusted in excess oxygen, to form products in standard states under standard conditions. In standard enthalpy change of formation, we can say that it is the enthalpy change when 1 mole of product is formed. From its elements in standard states under standard conditions. Now in given options, we can see that 1 mole of carbon dioxide is present, 2 moles of carbon monoxide is given, so it is incorrect. There must be 1 mole of substance and 1 mole of product. In 3, we have 1 mole of carbon dioxide present, so it could be correct. Now second thing is to look at the reactants. In 1, we have elements in their standard states. Carbon is in solid form, oxygen is in gaseous form, so it is enthalpy change of formation. And it is also enthalpy change of combustion because 1 mole of carbon is being combusted in excess oxygen to form product. So 1 is correct. In 3, we can see that carbon monoxide reacts with oxygen to form carbon dioxide. So as carbon monoxide is not an element, it must be an element for enthalpy change of formation. So therefore 3 is wrong. As only first option is correct, the answer is D. Question 34. The temperature of a reversible gas phase reaction is increased. Which statement are always correct? Part 1. More product is present at equilibrium. Now this is true only for endothermic reactions. As for endothermic reaction, when temperature is increased, what happens that more product will be formed as the reaction moves in the forward direction. But this will be wrong in case of exothermic reaction, because in exothermic reaction the reaction will move in the backward direction. So less product will be formed. So option 1 is not always correct, so therefore it is wrong. 2. The average speed of the particles increases as we are increasing the temperature, so therefore what happens that it will increase the kinetic energy of the molecules of both reactants and products, so therefore average speed will also increase. Number 3. There are more successful collisions per unit time. As we are increasing the temperature, the kinetic energy is increased, number of collisions will increase. So therefore there is a chance that more successful collisions will also increase. As option 2 and 3 are correct, the answer is therefore C. Question 35. 3 samples of chlorine gas each contain 0.710 grams of chlorine. Each sample is reacted with a reagent. In the first reaction, a sample is reacted completely with hydrogen gas. In second, it is reacted completely with cold sodium hydroxide. In third, it is reacted completely with hot sodium hydroxide. Which masses of the named products would be formed? Let's first write the balanced chemical equation. For first reaction, we have hydrogen gas, chlorine gas. It will form HCl. Now we can see that in balanced equation 1 mole of chlorine forms 2 moles of HCl. Now we can find the moles of chlorine by using this mass, and the molecular mass of chlorine is 71. So dividing mass divided by molecular mass, number of moles of chlorine come equal to 0.01 moles. Now if 1 mole of chlorine forms 2 moles of product, then 0.01 mole of chlorine will form double amount of product. So it will be 0.02 moles of HCl. Let's convert this number of moles into mass. The molecular mass of HCl is 1 for hydrogen, 35.5 for chlorine. So overall we have 36.5. Mass in grams is equal to number of moles into molecular mass. Putting values, number of moles is 0.02, molecular mass is 36.5. So it comes equal to 0.730 grams. Now in option 1 we can see that exactly 0.730 grams of HCl is formed. So option 1 is correct. Now doing the same for second reaction. The reaction is between chlorine and cold sodium hydroxide. Balanced equation will be like this. As in the option they have given NaCl, so we are concerned only with sodium chloride. In balanced equation we have 2 moles of sodium hydroxide being reacted to form this product. Now we can see that the ratio of chlorine with sodium chloride is 1:1. So it means 0.01 moles of chlorine will form 0.01 moles of sodium chloride. Now converting these moles into mass, the atomic mass of sodium is 23, for chlorine it is 35.5, so in total the molecular mass becomes 58.5. Mass in grams is equal to moles into molecular mass. Moles is 0.01. Molecular mass is 58.5 for sodium chloride, so it comes equal to 0.585 grams. In option 2 we can see that exactly 0.585 grams of sodium chloride is formed, so therefore this is also correct. Now option 3, chlorine is reacted with hot sodium hydroxide. Now the product formed will be like this. In the balanced equation we have 3 moles of chlorine that react with 6 moles of sodium hydroxide to form 5 moles of sodium chloride and 3 moles of water. So now the ratio between chlorine and sodium chloride is 3:5. As we have 0.01 moles of chlorine, so x moles of sodium chloride will be formed. By cross multiplying we can find the value of x. So now the number of moles of sodium chloride come equal to 0.01667 moles. The molecular mass of sodium chloride is 58.5. Converting these moles into mass, mass is equal to moles into mR. The answer comes equal to 0.975 grams. In option 3 exactly same mass is given, so therefore 3 is also correct. As all 3 options are correct, the answer is A. Question 36. Solid barium oxide is added to some ammonium sulfate solution in a test tube and mixture is warmed. A piece of damp red litmus paper is held over the mouth of test tube. Which observations would be made? As we have solid barium oxide, now what happens when barium oxide is added to this solution? Barium oxide also dissolves to form barium hydroxide. It will react with ammonium sulfate. And as alkali reacts with ammonium salt to form ammonia gas along with salt and water. Barium sulfate will be formed in the form of white precipitate as it is insoluble. Ammonia gas is formed, which is basic gas. Option 1, the damp litmus paper initially turns from red to blue. This is true because basic gas is formed and basic gas turns red litmus to blue. Option 2, a white precipitate forms in the test tube. As we can see that barium sulfate has formed, which is white in color, so therefore option 2 is also correct. Number 3, a brown gas is evolved with strong heating. Now brown gas is NO2 and NO2 is not formed upon strong heating. So option 3 is wrong. As option 1 and 2 are correct, the answer is therefore B. Question 37. Which compounds show geometrical cis-trans isomerism? For cis-trans, there should be two things. One, a double bond must be present. Second, the carbon atom making double bond must be attached with two different elements or groups. Let's draw this option 1. We have CH3 bonded with carbon. Also hydrogen is present. Then on second side we have CH3 and C2H5. Now as we can see that double bond is present and also the double bonded carbon is attached with two different groups on both sides, so therefore it will show cis-trans isomerism. Now drawing part 2, we have CH3, carbon, hydrogen is also present. Then we have carbon with hydrogen and CH2, CH2, CH3. Now we can see that double bond is present and also double bonded carbon is attached with two different groups or elements on both sides. So therefore this will also show cis-trans isomerism. Option 3, we have C2H5. Hydrogen is also present with carbon. Then on second side we have C2H5 and hydrogen is present. Again double bond is present and the carbon that is making double bond is attached with two different groups. This carbon is also attached with two different elements or groups, so therefore this will show cis-trans isomerism. As all three options are correct, the answer is therefore A. Question 38. Which pairs of compounds may be distinguished from each other by testing with alkaline aqueous iodine? Now alkaline aqueous iodine gives positive result with these compounds. If it is an alcohol, there must be CH3 attached with the carbon atom having OH and it shouldn't be tertiary alcohol. If it is aldehyde, then there must be CH3 directly attached with the carbonyl carbon. If it is a ketone, then there must be a CH3 group directly attached with carbonyl. Let's look into the options. In 1 we have ethane 1,2-diol. Let's draw. We have two carbon atoms as it is ethane. On first carbon and second carbon we have alcohol groups. Second is ethanol. As we can see that in ethane 1,2-diol, no CH3 is attached with OH carbon, so therefore this will not give positive result. In ethanol we can see that CH3 is present with carbon having OH, so this will give positive result. So we can distinguish both these by using alkaline aqueous iodine, so option 1 is correct. Option 2, we have propane 2-ol. In propane we have 3 carbon atoms and 2-ol means that OH is on second carbon. Second is methyl propane 2-ol. So again we have propane 2-ol and methyl group is also present on second carbon. As in propane 2-ol we have CH3 attached with the carbon atom having OH, so it will give positive result with alkaline aqueous iodine. Methyl propane 2-ol we can see that we have tertiary alcohol as this carbon is attached to 3 other carbon atoms, so therefore oxidation of tertiary alcohol does not take place. It won't give positive result with alkaline aqueous iodine, so we can differentiate these two based on this test. In 3 we have ethanol. Ethanol is having 2 carbon atoms and alcohol present. Butane 2-ol. In butane 2-ol we have 4 carbon atoms in the long chain and we have secondary alcohol group. As we can see that in ethanol CH3 is attached with the carbon atom having OH, so it will give positive result with alkaline aqueous iodine. Again in butane 2-ol we can see that CH3 is attached with the carbon atom having OH, so this will also give positive result with alkaline aqueous iodine. As both will give positive results, so therefore we cannot differentiate these two based on this test. As option 1 and 2 is correct, the answer is therefore B. Question 39. The diagram shows an experimental setup which can be used in several different experiments. We have this experimental setup. Which processes could be demonstrated by using above apparatus? First one is the oxidation of ethanol, which is liquid X. So this is liquid X that is present here. What happens that in the presence of silica or alumina is Al2O3. Upon heating, it will cause dehydration of alcohol. So therefore, under these conditions, oxidation cannot occur, so option 1 is incorrect. Option 2 is dehydration of ethanol. Now we can see that ethanol is also alcohol and alumina causes dehydration, so therefore option 2 is correct. When ethanol, which is CH3CH2OH, it is dehydrated, it forms alkene along with water. Now alkene is ethene. Ethene is a gas, and this gas is insoluble in water, so it can be collected upon water. Option 3 is cracking of paraffin. Now cracking means converting long chains hydrocarbons, which is paraffin, into shorter chains upon cracking. Now this is possible if it is heated in the presence of these compounds, so option 3 is correct. The shorter chain hydrocarbons formed are insoluble in water, so therefore they can be collected upon water. As option 2 and 3 are correct, the answer is C. Question 40. The ester. This is the ester can be made in school or college laboratory by a sequence of 4 reactions or fewer using compound Z as the only organic material. What might be the identity of compound Z? Let's first draw the structure of this ester that is given. We have CH3CH2 as C2H5 is given, so I have divided it into 2 carbons. Then we have C double bond O, O, then again CH2, CH2, CH3. Now this ester can be divided upon carbon-oxygen bond, and this portion is of carboxylic acid. So it can be made from this carboxylic acid, which is 3-carbon carboxylic acid or propanoic acid. The second part comes from alcohol, so we have 3-carbon alcohol, which is propanol. Let's look into the options. First one is 3-carbon alcohol, that is propanol. Now propanol can be oxidized to propanoic acid. And propanol will react with propanoic acid to form this ester. So option 1 is true. In option 2, we have 3-carbon aldehyde. Now 3-carbon aldehyde can be oxidized further to 3-carbon carboxylic acid, which is propanoic acid. And we can also reduce 3-carbon aldehyde. Upon reduction, it will convert into primary alcohol, which is 3-carbon alcohol, also known as propanol. So propanoic acid and propanol both will react to form this ester, so option 2 is also correct. In option 3, we have ketone CH3, C double bond O, CH3. Now ketone cannot be further oxidized to carboxylic acid, so therefore it will not form carboxylic acid. Ketone can be reduced into secondary alcohol. Now secondary alcohol will not form this product as we need primary alcohol for this ester. And also carboxylic acid is absent, so therefore C is wrong. As option 1 and 2 is correct, the answer is B.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.